St Mary's Catholic Primary School in Birmingham. Earlier this year, we visited the school to see how primary science is taught and, more importantly, how children learn. In the lesson, we saw how Year 6 were encouraged to act as scientists. In small groups, they were asked to make predictions, establish fair tests, and encouraged to work independently to develop their scientific thinking. We followed one of the high flyers of Year 6, Nicole, as she made her way through a science lesson on plants and growing. Nicole's science teacher, John Blaney, who's the Deputy Head and Science Coordinator, invited Jane Turner from the East of England Science Learning Centre to review and discuss his lesson. Year 2 teacher, Veronica Knight, also sat in on the discussion.
Right, John, that was a really interesting lesson, lots and lots going on. We focused on Nicole. Perhaps you can tell me about Nicole as a learner. You know, what's she like in the classroom generally?
I think she's an independent learner, really. She's at a stage in her school life now where she needs a little bit more challenge. She needs to feel that she can maybe take a bit more charge of her learning, and we try and give her, and children like her, those opportunities in science particularly. Yeah,
I mean, she was very independently getting on and sorting out a lot of information very well. Veronica, you, by watching that lesson, what do you pick up from?
I was very impressed by how thoughtful Nicole is. She didn't immediately jump to answer questions. You could actually see her thinking in several of the shots. I thought she was a very good leader of the group. She helped them, but she didn't dominate them.
No, I agree.
It was fun, like, asking people questions, then asking them to answer you. You have to sort of think about what you're going to say before you say it, and you have to think on the spot a lot.
Helping the seed disperse?
Yeah, because inside of this, in the little sort of flappy bits there, the seeds are inside that.
She was very reflective as well, to be able to articulate what it was like to be at the front of the class and how you have to think is really quite a sophisticated skill, and I thought she did that really well. She was very aware of her learning, really, or aware of what she was doing, which was great.
What is this plant?
I was particularly pleased with the way that she and Anthony took charge of that PowerPoint. They labelled the pictures as they saw fit, asked questions of the class and fed back to the class, and enjoyed the teaching experience. And I think she needs to download some of her learning and pass it on.
Yes.
Which is quite interesting.
But it was a really good formative assessment strategy. Rather than you starting off saying, this is what we need to find out, you said, what do you already know? And they told you. So as a teacher, you're able to say, well, they know this, they're not so sure on this, so that's the way I'll push the lesson. Whereas if you'd started off with what you thought they needed to know, you might have started off too low or too high, whereas that was a perfect way of getting exactly what they knew and giving them that independence.
So,
how long did the children take to do the planning part of that activity?
I think that was a quick part of the lesson because they write up their notes on the sticky papers, put them on the chart in a matter of maybe 5 to 10 minutes. Great advantage of post is just get your ideas down, let's discuss it, share the best of it, and then get on, get into the practical work.
No, I agree. They were certainly very efficient at it, and they discussed it beautifully together. So yeah, 5-10 minutes planning, and then that leaves a great long time for doing.
The whole class can collect their ideas together, and we can talk about it as a class, then they can break up into groups.
Yes.
You're changing light, then what all needs to keep the same? The amount of water?
You'd have to keep the place where it was in the same, otherwise it might...
What shall we write for that?
Nicole and her peers were handling 2 different investigations. They were looking at germination and plant growth. They were changing a multiple of variables. They were deciding totally for themselves how they would do it, how they would carry out the investigation, how they would record it. That's really high-level scientific organisation.
Nicole's group have decided on the factors affecting a seedling's growth, and she's off to put their pink sticky note on Mr. Blaney's chart. But she seems a bit unsure of where to stick it.
She was wondering whether, when she changed the light conditions, would she put it under the germination section, or would she put it under the seedling growth section? And she had to ponder a little bit there. I'd like to think she was hesitating because she knew to germinate the seed doesn't need light,
That chart was an excellent framework for their planning and organisation, but quite complex. And perhaps with slightly younger children, you might have had one for germination and one for seedling growth, because children do confuse the two.
It's based upon charts that we've used through the year, which have been maybe a little smaller. This is the first time I'd made a kind of great, totalizer sort of thing of all their thoughts. I've still got it on my room wall. Well, it's all there, you see,
yes.
So you can actually refer back to that.
Yeah. And Nicole was handling all the information by herself. Now, how did you get her to be able to do that?
Well, I think it's a question of introducing it earlier on in the year, giving the children something to think about, like they might think about, what are we going to do to keep this investigation fair today, and let them brainstorm between one another. We want the children to start thinking for themselves. So yes, that is happening, and as I kind of move up and down school as the science coordinator, I'm seeing it more.
I've given you some bits of equipment that I've found. I wonder if you can think of a way to control the amount of light to each of the plants, because you have to vary that. Any good ideas so far?
It relies on Nicole and her friends really having a very clear understanding about what we want to change, what we want to keep the same, what a fair test looks like, and knowing the different potential there is for measurement. How can we measure this? What are the different ways we could do it? What are the different ways of recording? You have to have built up those skills.
You build up those skills through the school, really, but by year 6, hopefully it's the icing on the cake, and they've got all those skills, and how can they apply them?
Yeah.
I can see a clear progression from the year 2 children to year 6 level. It's probably the reverse, in that most of the children are able to go ahead independently.
That's true, actually, yeah.
It's that balance you're trying to develop, isn't it, of retaining that real curiosity and enthusiasm, but giving them the skills which they can actually follow it through. Because we can all have limitless enthusiasm and questions, but if we haven't got the skills, they wouldn't cope with what they were doing there. They need to have that theoretical, step-by-step, systematic, this is how we do it.
If we were to just pull it up, then the leaves would probably break, so we have to sort of try and gently dig it out. No, I'm not yet.
When they get to this point in Upper Key Stage 2, it's great to say, well, I'm not quite sure how we're going to achieve that today, but over to you. Can you come up with some ideas?
Yes.
And sometimes, genuinely, as a teacher, you're not quite sure how they'll manage that. And it's great when they come forward and say, well, we've done this, this and this.
We're thinking about putting tin foil over the top with the different experiments, putting holes into the tin foil, or using one in total darkness by having the canister on it, then another one in slight darkness by having tin foil sort of like, and we'll pierce some holes to see so that it lets in some light, and then on the other one more light again.
Life cycles is a year 3-4 topic, isn't it? But you were repeating it, but in a way that was totally accurate and apposite for year 6s, because you gave them so much independence. So they were working at level 4, level 5 in terms of science 1, and repeating stuff that they will need to know for their SATs in a way that was entirely appropriate and challenging, and that was really excellent.
How's it going over here?
Sometimes you find that one group works faster than another. If they're all doing the same investigation, then what's the point of going through it, because that group's already finished. So that's a really good way of making sure you had a multiplicity of things going on, but with the same structure.
We'll just put one slot in ours.
What made that a good lesson was that there was lots and lots of practical work.
Hands-on is what children enjoy and what they remember.
Yeah, exactly.
And when things go wrong as well.
Yeah.
Not all the time, but I think when things don't go slightly as they thought it would go, it leaves more questions.
Yeah, science does go wrong, and sometimes that's how you learn something new, or it might be that, we're asking children to evaluate not just the outcome, but the process by which they reach that outcome.
This one will grow quite tall. You may have to actually change this and make it bigger, but still keep it in complete darkness. This one will grow quite well because it'll be quite healthy because it has enough light and it's got everything else. We don't think that this one will grow too well because it's only got a small bit of light, but it may grow quite quickly upwards because it's searching for the light.
Nicole coped really well with that lesson. Was it a challenge? Did she learn anything?
I believe she did. She was challenged at various points in the lesson to, first of all, collect some information that she could feed to the class at the beginning. But really, it was within the problem solving of setting up that investigation, the variation of light, She's working with a mixed ability group.
Right.
And I think she modelled some of her scientific understanding really to them. They were very conscious of the fragility of the plant, and she came up with the idea of pushing it from the end rather than pulling it up by the leaves.
Right, now there's one. Yeah.
Yeah, she definitely learned team skills, and she definitely solved a few problems for us.
Yes, she did. I mean, she didn't leave one without any cover on it. They had total cover, minimal and a bit less. They didn't have one open all the time. They didn't question the fact they were going onto the light bank and would have 24-hour light compared with normal conditions. So there were some other areas where she might have been pulled a little further, but she...
That's a good point, yes. 24-hour lighting is quite an unusual concept, really.
But
yes.
a really good link into, well, how can we eat vegetables at the wrong time of the year, and how do they get flowers early in the spring? What happens? How do commercial growers work? So in terms of broadening the curriculum and to that sort of real-life application, really valuable. You had fast plants there, those rapid-growing brassicas, you had a light bank. And as Nicole said, Mr. Blaney says, we're young scientists. Well, that makes them feel like a scientist.
That's true.
So what does science mean to Nicole?
To do experiments and think scientifically.
I mean, she said scientific thinking, which was just great. Nicole has shown us that she's learnt her science and understands her science through a thinking, doing process.
Yeah. Yeah.
You know, all the research says that's how children learn and understand better. We could put all the facts on the board. It would have taken 10 minutes for you to write them up and they copy them down in their book. Factors for germination and plant growth. No learning would have gone on. So that was really important.
I think we want to give them a bit of a launching pad, you know, for Key Stage 3. So they are very much interested in the practical side of science, the good questions.
Sometimes teachers get nervous at the end of Key Stage 2 that, oh gosh, they're moving into Key Stage 3 stuff, but what you've done is given them more independence and a chance to deepen and enrich what they're doing without necessarily moving them on to concepts which are Key Stage 3 concepts. And the fact that you gave them so much independence is really the way to extend those able children, I think. John, I'm going to ask you to be self-critical now. If you were doing that lesson again, is there anything you would do differently?
Maybe I would like to have asked her maybe a challenge question, maybe dropped it in maybe within the lesson and let her talk about that. It could have been something to do with seeds and what seeds are really and how they transform from such a small thing to such a large thing. Just give them a challenge, a bit of thinking.
Or a question like, does a bigger seed make a bigger plant? Does a bigger seed grow faster? You know, there's just adding a little more challenge to it. So you'd keep the variables the same, but just the question is slightly more challenging.
Yeah. Jane, thanks for all your advice today and input and comments on the lesson. It's been very helpful. Do you have any suggestions for us? See how we could develop that a little bit further and which ways?
I think there's various ways. I mean, it was great to using a light bank. I think you could introduce more technology in terms of recording. I think data loggers would be a real asset with those children. Another really nice piece of technology is if you'd had a digital camera, children upload their photos for the plenary and say, well, this is when we were doing this bit and this is where we struggled here. So that works really well, and I think that would have been nice. And as you mentioned earlier, just throwing in some challenging questions, ones that just take them outside of the comfort zone, really.
Keep them thinking all the way through.
Keep them thinking, yeah.
Thank you.